whenever you have two components in a system that work together, they're coupled. It doesn't matter what these components are, whether you're looking at services, microservices working together, or two methods within one object. They work together, they have that reference, we have coupling. Now, the nature of that coupling is reflected in three dimensions. The first dimension is the strength of that integration between them. And this one is reflected by the amount of knowledge that is being shared across their boundaries. Now, if you have two components, they know nothing about each other, they cannot work together. For the integration to work, they have to know something about each other. And that something, that knowledge, it's not related to the business data that flows across them. It's more about the format of the data, maybe some implementation details, maybe some functional definitions, etc. The bottom line is the more knowledge is shared, the more these two components will have to change together. One bounded context should be implemented by one team only. That team should be responsible for that bounded context, and that's it. Why? Because we want to make sure that knowledge about that particular area of the business domain is handled in a limited group of people, by a limited group of people, and we have the best possible, most efficient possible communication between them. Other way around, one team can work on multiple bounded contexts, that's fine. A bounded context has to be owned by a single. People are getting used to pain. They ignore the pain. Pain it's not pleasant to most of us, but it's very important. It's important because that's how our body tells us what's wrong. Same in software design. Like, we learn to ignore things that annoy us, things that break when we touch them. And I would say the first step is to start identifying that pain. Make sure you know what hurts the most in the system. And then ask why it hurts the most. And to answer that question, you have to get into a strategic domain-driven designs part that's called domain analysis. You have to understand the business domain to identify its subdomains and to categorize them. So for me, that moment when it finally clicked was von Vernon's papers. He published 3 papers on effective aggregate design. It was even before the Red Book. So when I read those 3 papers, like, okay, I finally get this, that aggregates are not just glorified entities. We have this thing of transactional boundaries, and we have to take care of it.
Today on Señors Scale, we're joined by Vlad Kononov, software architect, keynote speaker, and the author of Learning Domain-Driven Design and his new book, Balancing Coupling in Software Design. Vlad has spent over 2 decades helping organizations untangle complex systems, make sense of messy business domains, and evolve software architecture that can actually scale. Thank you for joining me, Vlad. Glad to have you on board.
Yeah, it's a pleasure being here. Thank you so much for inviting me, Dan. So you're starting with heavy questions, I see.
Yeah.
Heavy artillery from the
5G.
get-go.
Eli 5G.
Yeah. Yeah, so I would ask, who are you? Are you a software engineer or you're more business domain expert, let's say?
Let's say software engineer, and my
Software engineer.
listeners are software engineers, yes.
I see. So I would say that as software engineers, our goal is not to write code, but to solve problems for businesses, right? And that's how the code we write becomes valuable. Now, in order to solve problems for businesses, we really have to make sure we understand those problems. And only then we can design our solutions that will meet their needs the best way possible. So domain-driven design is a methodology that gives you tools for getting into business domains, understanding their needs, strategies, etc. And it gives you tools how to convert that knowledge into technical design decisions.
Great.
That's how I would explain domain-driven design.
And what made you write your Learning Domain-Driven Design book in the first place?
So to be specific, I started working with O'Reilly in 2018, I think, or 19.
Mm-hmm.
And back then, they asked me to write a report, which is like a really short book. It's 80 pages. We agreed that it's going to be 40 pages, but estimate software engineers. So it ended up being almost 100 pages. And my goal was to write something short, something that somebody can read over a flight, over 1 hour, 2 hours, and get like understanding of what domain-driven design is and what is the goal of each one of its core components.
Mm-hmm.
And to be honest, that book was more oriented towards business people. That was my goal. I was thinking that, hey, for software engineers, we have Blue Book, we have Red Book. Come on, let's write something for domain experts. And so I wrote that report, 88 pages, if I remember correctly. It was locked on O'Reilly's online learning platform, and people liked it. And suddenly I started hearing like positive feedback about it from software engineers, like from a different audience. And they're asking, hey, I want to buy this. I want to distribute this book locally at my company, etc. And it's not possible. So we started talking with O'Reilly about doing that. How can we unlock the book from their platform? And of course, they said, okay, we cannot do it. And we also cannot put a sticker with an animal on it and sell it because it's too short. So we agreed that, okay, we're going to add 2 more chapters, make it a bit longer, call it Learning Domain-Driven Design, and then it will be free to distribute whoever wants to buy it. Again, me being a software engineer, estimates, so I ended up rewriting the whole book. And now that the audience shifted, I wanted to delve into different levels of detail. So it ended up being 300 pages instead of 120. But yeah, that's how the decision was made. So it was kind of a stone soup. First, we wanted to distribute the report, add more chapters, and I ended up writing the whole book.
That's really cool. So, what were some of those early moments in your career when DDD finally clicked for you? What made DDD click?
Yeah. So first of all, for me, the most important part of domain-driven design was that finally I have that answer. I have guidelines how to implement business logic. Because I remember my first job, my first week there, and we were going over layered architecture, data access layer, and then like a whole lot of techniques, patterns, and stuff that's how we do data access layer here in the company. Same for presentation layer, and nothing for business logic layer. So I felt like something is missing, and I found that missing piece in domain-driven design. Now, for me, the Blue Book was quite challenging to read, and I needed a few attempts to finally finish reading it because, I'm not a native English speaker. So for me, that moment when it finally clicked was von Vernon's papers. He published 3 papers on effective aggregate design. It was even before the Red Book. So when I read those 3 papers, like, okay, I finally get this, that aggregates are not just glorified entities. We have this thing of transactional boundaries and we have to take care of it. So that was the moment for me.
So, what do you think are the main building blocks of domain-driven design? Like you said, aggregates. What else? What makes domain-driven design different?
I'm talking about aggregates, but in my opinion, that part is optional. It could be removed from domain-driven design. So domain-driven design can be, all these techniques can be split into 2 groups, strategic design and tactical design. Tactical design is the cool stuff. That's the stuff we want to do as software engineers. And strategic design is the stuff we have to do in order to be effective when implementing technical design decisions. Now, strategic design is the important part of DDD. If we can use terminology of domain-driven design, in my opinion, ubiquitous language, that's the core subdomain of DDD. That's like the most important part. Finding that common language and bridging the communication gap between 2 worlds of business domain experts and software engineers. And it clicked for me as well, because not long before I started reading domain-driven design for the first time, back then I was studying in the university and I was doing a research about software projects and why they're failing so much. It was interesting, and I said, okay, if I do a good job with this research, I will be able to use it in my job. If something fails, hey, we have the numbers, it's not my fault, right? So I was really interested in that research, and the conclusion was, based on the information I found, like there are many different reasons for why software projects fail. But if you analyze each and every one of them, all of them have something to do with communication. Something about broken communication between business and software engineers, or even among software engineers themselves. And then I read about that notion of ubiquitous language, that it's important to find a common language that everyone on the team will understand. So that's, in my opinion, the core subdomain of DDD. Now, you cannot build a ubiquitous language that's going to cover the whole company. If the company is doing something bit non-trivial, it's not going to work, because it's going to be very complicated and it will be full of inconsistencies. So then we need bounded contexts. Bound contexts are basically boundaries around smaller ubiquitous languages. So you define multiple dialects that are being spoken at the company, and you just define the boundary where each dialect in what situations can be used. So in my opinion, these are the two most important parts of domain-driven design: ubiquitous language and bounded contexts that enable it.
Yeah, makes sense. For teams that are new to DDD, what's like a misconception that you always hear about it? One thing I always hear is like that it's over engineering or stuff like that, and I don't agree with it. What's your take on it?
Yeah, so look, when I started implementing domain-driven design for the first time, I read those first 5 chapters from the Blue Book. I got to entities, value objects. Cool, I'm ready. I'm ready for it. Let's do it. So everywhere I looked, let's put an aggregate there. Eventually, that solution was very, very over-engineered and simultaneously under-engineered, because those weren't aggregates at all. And many people are doing that mistake. They focus on the cool stuff, again, stuff that we software engineers love, and do not pay enough attention to strategic patterns, strategic techniques for understanding the business domain and for designing its bounded contexts. When that happens, then suddenly, the technical design becomes so much more complicated. You end up with huge aggregates, and they're not effective. Suddenly you have inconsistencies between aggregates, and then people say, okay, domain-driven design doesn't work.
Yeah, I got it. What are some anti-patterns that you've saw in your career in domain-driven?
Anti-patterns. Well, that is the first one.
The first one,
Focusing only on technical patterns, and I would say that's the most common one. Also, in domain-driven design, so let's say we identified those bounded contexts, which are again boundaries of ubiquitous languages, and then you use them for defining physical boundaries of components in your system. Let's say services, microservices, whatever you want to call it. They have to work together. The system cannot be just a collection of bounded contexts. They have to work together. That's part of designing the interactions between them. It's also part of strategic DDD, and it can cause some problems as well if you're not paying enough attention to the details, to the reasons for each of the patterns that define different integration scenarios, because some work better in smaller companies, where you have well-established communication and collaboration between teams. But if you will use the same pattern in a different company, like huge enterprise, or maybe even the same startup grows into an enterprise, suddenly those patterns that were so effective before will lead you to a disaster, like to nervous breakdown. Yeah, so I would say that's my number two most common anti-pattern, not paying enough attention to the interactions cross-bounded context.
How did, in your personal opinion, like in your experience, how many projects start with DDD from the get-go, like a Greenfield project that starts with DDD as an architecture? Or what's more popular, this or migrating from a legacy project to a DDD architecture in the meantime? What do you see happening more?
Yeah, I would say that a Greenfield project that starts with DDD from the get-go, I would say that's pretty rare. Like, I was lucky to be on such a project. That gave me such an important experience, but I was lucky. and, and that's pretty rare for the obvious reason. If you have a team of people, we all love domain-driven design, but let's be honest, it's not that popular that you will have a chance of working in a team in which everyone knows domain-driven design. Usually it starts without domain-driven design. Let's say startup company, the business works, the solution grows into a monolith, into a big ball of mud, and then we need to fix it somehow. And then, okay, that domain-driven design thing can help us. And then companies ask for training, ask for consultants. And yeah, that's in my opinion, the majority of DDD projects. Now, even in this case, I'm usually advising against like refactoring the whole thing to follow DDD, but only to focus on those important parts. Like, hey, that's the core business. Let's invest our efforts here. The rest, if it works, why touch it? Just make sure you have like an explicit boundary around that spaghetti code and the refactor part of the system. So number-wise, I would say that like even in brownfield projects, DDD affects only about 20% of those brownfield projects.
And how would you recommend someone start with this? They have a big monolith, they want to go to DDD. What's the first thing you recommend them do? How do you organize them?
Yeah, look, I really want to say it depends, but I'll try to be more useful. Look, let's say that you are working on a brownfield project for a long time and more functionality is added to it, that the design is not always the optimal one. There is some technical debt that grows over time, and eventually you have this monster. At this point, people are getting used to pain. They ignore the pain. Pain it's not pleasant to most of us, but it's very important. It's important because that's how our body tells us what's wrong. Same in software design. Like, we learn to ignore things that annoy us, things that break when we touch them. And I would say the first step is to start identifying that pain. Make sure you know what hurts the most in the system. And then ask why it hurts the most. And to answer that question, you have to get into a strategic domain-driven designs part that's called domain analysis. You have to understand the business domain to identify its subdomains and to categorize them. Are you looking at a part of the business that can be called its core competitive advantage? Like, hey, this is how our company is making money. That's why we are better than competitors. That's why our customers prefer us over other companies. Or maybe that's something that is not core business functionality. For example, something that we had to do, like something really boring, like CRUD data interface, or maybe even something that could be solved by using an off-the-shelf product or open source solution or managed service, etc. So basically, it all boils down to three types of subdomains. One is called core subdomains. If you're reading other books on domain-driven design, you will see the term core domain, but in the Blue Book, there are two ways to say it. Eric Evans says core domain in the majority of the book, but there is one chapter where he says core subdomain. I prefer that way. So I will say core subdomain. Yeah, so we have that core business functionality. And this part is going to change the most. So that's where you have to invest your efforts, because every change there has to be as smooth as possible. So that's one reason for pain. Like, you are working on core business functionality and it changes frequently. So you have to improve the design, and then, your nervous system will thank you in the future. On the other hand, it could be something that, let's say, something boring, or in DDD terms, supporting subdomain. Something simple, boring, something that you have to do to make sure it works. And the property of such supporting subdomains is low frequency of changes, much lower. So if you have pain there, you have to start thinking about how that thing integrates with my core subdomains. Something is wrong in those integration paths. Something causes frequent changes from the core functionality to cascade all the way down to supporting subdomains. Same is true for generic subdomains. Ones where you can use an existing implementation, somebody else has already solved the problem for you. You just have to accept their solution, and that's it. But when you're doing it, you have to make sure that there is boundary between that third-party solution and the rest of your system. Because if any change in your core subdomain will trigger cascading changes in the way you're integrating that generic subdomain, then again, there will be pain. So again, in that case, you have to look at the way the functionalities are integrated. Going back to your question, I would prefer to start there, to start with the pain and then track the source of that pain. And once you know that, the idea has enough tools to guide the process on how to deal with that pain, whether the pain originates from bad, I don't want to say bad, but let's say not efficient implementation of a core subdomain, or the way the components are integrated in the system.
Have you ever noticed like an organization that naturally flows into domain-driven design, like Conaway's law, because the organization is set up in such a way, and then the teams are created to fill the organization needs, and they're doing DDD without even knowing. Like, for example, I think in every company that I've worked, there was an order team that was responsible for orders. They had their own microservice that was orders, and in a way, they were doing domain-driven design. They had their ubiquitous language. Have you noticed this more and more often?
No. Usually, to keep things organized in a project, you have to invest energy into it. That's
Hmm.
the law of thermodynamics. Unless you invest energy, entropy will increase over time. So usually people want to invest that energy in some short-term goals, let's define it that way. And the big ball of mud starts rolling and growing. Now, on the other hand, I have encountered people that were not familiar with domain-driven design. However, their experience in the field led them to the same conclusions as domain-driven design methodology, as Eric Evans. So they're not using domain-driven design terminology, but in the way they're approaching problem solving, they're using the same ideas, just using different terms.
Mm-hmm. I got it. But have you ever seen a team, like a company or a team, try to do this, apply domain-driven design, and fail? And why did they fail, actually, if you saw
So I experienced that firsthand. Like, why
it?
should I talk about someone else? I can tell you about myself.
Perfect. What happened? What went wrong?
Yeah. First of all, again, we're getting back to the same idea that if you ignore strategic DDD and you focus on tactical DDD, you will end up with something bad. That was my first failure with DDD. Second, it took me some time, to understand that it's not enough to learn about the business domain, but you also have to watch how that domain evolves over time. Because if you identified subdomains and you put those labels, core supporting generic, that is fine. But it's correct only for today. What's going to happen in a month, in a half a year, in a year, who knows? The types can morph. Now, if you made your design decisions based on the types, well, guess what? If you miss that point in time where types change, then those amazing design decisions are no longer amazing. They're counterproductive in many ways. So I would say that, to summarize that, for me, other DDD related failures were because I failed to identify those changes in the business domain or made assumptions about the business without properly verifying them with the business. Or no, it's okay to make assumptions, but you have to make assumptions explicit and watch over time whether they're correct, or maybe something in the business occurs that invalidates those assumptions. So that was a problematic point for myself.
And have you ever seen like in your experience, a time where defining boundaries between contexts tricky?
Yeah, it's all the time it's tricky. Because so when we're talking about boundaries of bounded context, then for people who are not familiar with DDD, so far I mentioned that bounded contexts are driven by the boundaries of applicability of ubiquitous languages. Now, in DDD terms, each language is your mental model of the business. And as such, that's a model of the business domain. Now, DDD says that because that's a mental model, people that work on the same bounded context, people that have the same mental model of the business domain in their heads, they have to work together. The communication between them should be as efficient as possible. As a result, one bounded context should be implemented by one team only. That team should be responsible for that bounded context, and that's it. Why? Because we want to make sure that knowledge about that particular area of the business domain is handled in a limited group of people, by a limited group of people, and we have the best possible, most efficient possible communication between them. Now, other way around, one team can work on multiple bounded contexts, that's fine. But a bounded context has to be owned by a single team. That means that boundaries of bounded contexts are driven by two things. First, we have boundaries of models or ubiquitous languages, and second, by social decisions, by the way people work in your company. Now, everything that relates to people, how they work, how they communicate, is complex by definition. So that makes the design of bounded contexts not trivial in many cases, especially if, let's say, you're working for a startup company and it is successful. If it's successful, then two things will happen. First, this system will grow because users will ask for more and more stuff. Yeah, no, they're your users, they're paying money, so you have to make sure that their needs are addressed, so functionality will be added. Now, to keep up with all those additional requests, the company itself will grow. So you will have more R&D teams to take care of those requests. And once you have more R&D teams, that means you probably have to redesign boundaries of bounded contexts over time. Again, you have to pay attention when that moment comes and when you should take care of it. And making such changes is not trivial. It's pretty much everything where people involved.
Now, I'm going to switch a little bit to your new book about balancing coupling and complexity. What's like some accidental complexity in large systems that you've seen so far?
Accidental complexity. Oh, where should I start? You know that meme with Goose that prepares himself to shout? Yeah, so accidental complexities can be everywhere. If you're looking at a system, let's say at the highest level of abstraction, you're looking at its services, the service boundaries, the way that system is decomposed into components. Maybe they're too big. So you have like Monolith that an enterprise company works on altogether. So you just call that a monorepo and invent a whole bunch of tools to make that possible. Or maybe you, like I did, heard about all that microservices craziness 15 years
Yeah.
ago and said, okay, that's what that thing is going to solve all my problems. And 15 years ago, if you go back in time and listen to podcasts about what a microservice is, you will hear some interesting stuff like something that is easier to rewrite than to modify. Something that you can measure by a pizza, by two pizzas. You have team that you can feed with two pizzas, and if they can work on that, that's a microservice. Now, that company where I first used DDD, we were like 2.5 developers. I was the half. And for us, two pizzas was more than enough. Come on. That wasn't a microservice. That was like your good old-fashioned monolith. Yeah. So let's say inefficient definitions of what a microservice is. That's a major source of accidental complexities on that higher level design. What else? If we go all the way towards low level design, or let's say lower level design, where the tactical design decisions are usually, if you remember, I was questioning how should we implement business logic, and we're not paying too much attention, unfortunately, still to that topic. If you go 10, 20 years to the past, you'll see that there were books with knowledge about that, except for domain-driven design. For example, Martin Fowler's Patterns of Enterprise Application Architecture. Yes. In the book, he outlines a number of methods, and he outlines that each one of them has its pros and cons. Like, use this when you have, let's say, simple business logic. If you have complex business logic, then use this approach. Fortunately, we've forgotten about it. And I see so many people like pick one approach to implement business logic and just do it everywhere, which means for sure, for some parts of the system, it will be fine. For others, it won't be effective. And usually, the areas where it's not effective belong to core subdomains. So you know the outcome.
In your new book, how do you define like balanced coupling? What do you think? What does it mean, like balanced? Way?
Yeah, I cannot answer that question because to answer it, I have to define what coupling is, because that's such a non-trivial question. Now, I myself was trained to think about coupling as something negative. Like, that's the label you put on bad design. Like, you have big ball of mud, monolith, and you have coupling. The three evils of software design. And then, of course, we have cohesion, which is good. Coupling bad, cohesion good. How do you define coupling? How do you define cohesion? Nobody cares. Now, so again, microservices, back then I had like such an utter disaster with microservices. Like, I listened to all those experts, what they're saying, what worked for them. I tried to do it and it led to disaster. And at that point I said, okay, I listened to what these people were saying, and they had said that if you do microservices, you will get a decoupled system. And then I look at my code base, which is like an altar of coupling, like coupled in all ways possible. So back then I said, okay, I want to understand coupling, like where that word came from, what it means, how do I measure that coupling, and whether we can find some model to define it that's going to be a bit more precise than gut feeling. That led me to, again, books from the past, things that were defined in the past, but we, as software engineering field, we very effectively forgotten about it. It was left in the past, and it was so unjust, in my opinion, because that knowledge is so important. Now, some of that knowledge came from methodology called structured design, which was defined in the late 60s, early 70s, model called kinesence, and some parts of domain-driven design. And eventually I came up to that model that answered all my questions. And for me, it was simple to use. And I shared it with people that were working with me, and I saw that it's easier for them as well. Like something that is very easy to remember, something that is very easy to explain. Unfortunately, unlike domain-driven design, because to get into DDD, you have to invest more effort. And yeah, and that's how that book came into being. So the model of that I defined in that book, I will describe it right now in a few sentences. Now, you cannot say that I am wrong because I haven't invented it. All I did was adapted things that we have forgotten over time. So coupling means one very basic thing. Whenever you have two components in a system that work together, they're coupled. It doesn't matter what these components are, whether you're looking at services, microservices working together, or two methods within one object. They work together, they have that reference, we have coupling. Now, the nature of that coupling is reflected in three dimensions. The first dimension is the strength of that integration between them. And this one is reflected by the amount of knowledge that is being shared across their boundaries. Now, if you have two components, they know nothing about each other, they cannot work together. For the integration to work, they have to know something about each other. And that something, that knowledge, it's not related to the business data that flows across them. It's more about the format of the data, maybe some implementation details, maybe some functional definitions, etc. The bottom line is the more knowledge is shared, the more these two components will have to change together. So we have that one dimension, integration strength. The second dimension is a more physical one, or shall I say, socio-technical one. It's the distance between them. So we have two components, they work together. As a result, they are sharing knowledge. Now, let's say that for reasons, like for legit reasons, they're sharing lots of knowledge. Like they're implementing closely related business functionalities. Which means whenever business requirements will change, they will have to change together. If they won't, then the system will be in an inconsistent state. So the two components share a lot of knowledge. Now, your design decision is what is the distance between them is going to be. Are you going to put these two components close to each other, maybe in the same folder, maybe in the same file, in the same repository, or are you going to make that distance bigger one? Like, let's say, implement them in different services or in different systems. That's like an extreme example. Why that's important? The longer the distance, whenever you will have to change them together, the bigger the distance, the more painful that change is going to be.
Yeah.
So if you have two components sharing lots of knowledge, then you have to make sure that they will be close to each other. Now, when they're close to each other, then it's almost as if you are changing one component. The cognitive load you will have to go through is going to be significantly lower. You won't forget about the distant part of the system that has to change as well. No, it's all here. Just change it. Now, it doesn't mean that you just overcomplicate stuff, like add accidental knowledge that shouldn't be shared, and then put everything in good old-fashioned Monolith and say that this is balanced coupling. No, that's not how it's going to work. You always have to identify from the business perspective what is the absolutely minimum amount of knowledge you have to share and refactor your code base to that minimal level. And then you decide. If it's high amount of knowledge, decrease the distance. Now, if it's low amount of knowledge, means that these components are not expected to change together. They don't have much to do with each other. And as a result, it's better to increase the distance between them. So with these two dimensions, you are basically putting related things together, close to each other, and you're spreading apart unrelated things. These are the two dimensions, strength and distance. Now there's this third one. And this third one comes more from domain-driven design. It's more inspired by domain-driven design. And it says it's basically about the rate of changes. Like, let's say that we have two components sharing lots of knowledge. The distance is big. Is that always a problem? Well, we have to identify the source of knowledge. The source goes in the opposite direction of dependency. Like if I depend on a component, then I have knowledge coming out from it, from the component I depend on. So the question is, the source of that knowledge, is it volatile or not? If it's going to change frequently, oh boy, I have a problem. I have to make sure that my design is ready for those changes, which means I minimize the knowledge across bigger distances. If I cannot reduce the knowledge, then I will have to reduce the distance. If, on the other hand, we'll use domain-driven design's model of subdomains or wordly maps, there are different ways to evaluate volatility of components in a software system. And you see that, hey, that source of knowledge is not volatile. In that case, it's okay to be more pragmatic and round some corners in these areas of the system, and instead focus your efforts where volatility is high. Now,
Mhm.
the trivial example here is, let's say that you have a legacy system, like a typical legacy system in a company. I guess many companies have them that work, that provide business value, but boy, does everybody in the company afraid to touch them, even to look at them.
Of course.
Now,
Especially like with checkout and invoices, stuff like that. You don't want to touch those.
yeah, yeah. Now you have that label legacy, which means
Exactly.
it is not being actively developed. So you want to integrate with it, it's fine. You can go straight into its database, take whatever you need, and continue with your job. Because again, the database schema is not expected to change because, again, that's legacy system. So that's more of a pragmatic dimension. So eventually, we have three dimensions. Strength, that should be inversely proportional to distance, and volatility. If it's low, I don't really care about the first two. So going back to your question from 20 minutes ago, before I started talking without stopping, what is balance? Well, balance is when these three dimensions are balanced. Either strength is inversely proportional to distance or volatility is low. That's the balance of.
I'm just glad I asked that question because you explained so much in so much great detail. I love it. Like I think you just did like a summary of big chunks of your book, so I think it's really, really cool. But you talked a lot about big systems. What are some tools that you use to map different components or different parts of the system? What do you like to use in your work?
You mean to document the architecture?
Yeah, document, draw the diagrams. What's what's your go-to?
Yeah, look, my approach is, I'm not sure everybody is going to like my approach, but basically, I prefer not to have that golden diagram
Mhm.
that reflects everything. Instead, I prefer to keep things as simple as possible so that you can keep it in your head, and just to create a diagram when needed and to map out the components of the system, how they're working, and make sure that everybody on the team is aligned with that. Um, That that approach is preferred for me for a number of reasons. First, again, if you go back 30 years ago, back then companies were proud of their ERD diagrams spanning like walls
Mhm.
in corridors and companies. Like, we're doing like serious stuff here. Just look at our ERD diagram. So if you end up with something like that, well, that's complexity. That's like the opposite of modularity.
Mhm.
That means you have, let's say, inefficient distances between things. Maybe you have to introduce a number of layers of abstraction. Now, once you cannot trust these, again, you have to model them in a more modular way. So you will introduce higher level components that will group related things, that will distance unrelated things. And second, I don't trust documents because in my experience, like, if the documents are really up to date all the time, then the business is not doing good. Like, we have way too much free time. So instead of providing business value, we are working on our diagrams. Now, again, that's not going to be true for all companies. I know that. I'm speaking about, let's say, startup companies, growing startup companies that I'm used to work for and to
Mhm.
consult. Maybe if you're in healthcare, in finance, different story. Again, my experience, the kind of companies I usually work with. So usually diagrams are not up to date, documents are not up to date. So the source of truth is in the heads of people working on those systems. From time to time, you have to synchronize that knowledge. And my opinion, the most effective way to do it is going back to domain-driven design is an event storming session, which is like a group activity where a group of people brainstorms what they're thinking about a certain area of the business domain and synchronize their understanding of it, synchronize their mental models. Yeah, so that's my preferred approach. Again, not everybody is going to like it, not everybody is going to agree, but again, I'm speaking out of my specific context.
No, I love it. Event sourcing, I think, is a really cool exercise, and a lot of teams need to do it at least once as a group activity. I think it's really cool. But do you think it exists something automatic that I don't remember where, but like you can inject something in your code base and it draws the diagram based on like observability, how messages pass through the system and stuff like that. Have you ever used something like this?
I tried using such solutions quite some time ago.
Hmm.
Now, quite some time ago, it's not like big numbers, like 5 years ago. Five
Okay.
years ago, the world was very different from what we are seeing right now. So today, such tools might be more useful. So I am not judging things that are available today because maybe I haven't used all of them. Back then, in those old days, like 5 years ago, I couldn't find something really useful for me because such tools back then were able to identify those connections, those references, but they focused on measuring coupling, identifying bad connections by counting variables that are being shared
Hmm.
across these connections. Now, in my opinion, that's counterproductive. There is more than one chapter about that in my book. It's not about the quantity of the data, it's about the nature of the data. What is the source of the knowledge that defines the data? If it's something that is defined for integration purposes and it's designed in such a way that will contain changes within the source of component that is the source of knowledge, I am totally fine. If business domain requires it, it's okay to share lots of data. On the other hand, you can share one variable over two components and it's going to be private variable read through reflection. Guess
Hmm.
what? If it's going to change, it will break. The first one, it's much more stable. So yeah,
I
that's why
understand.
my trust in such tools is not sky high. Let's say it that way.
One more question on domain-driven design. Where because now we're living in the AI age. Where do you think AI has a place in system architecture, domain-driven design? So for now, the way I see it, it's not that good. And it makes like a lot of mistakes and creates more problem than it solves when you.
Yeah, the thing that starts with A and ends with I. In my opinion, it makes domain-driven design way more relevant than ever. Like when
Hmm.
DDD was first coined, 2005, if I remember correctly, it was like a niche methodology that only the chosen ones that were able to finish reading the blue book were aware of. But people were like afraid of the word-bounded context. People like me were afraid of ubiquitous language because
Hmm.
as a ESL speaker, go try spell it. Now, as time passed, that microservices craziness came along. And suddenly a microservice is a bounded context. And a bounded context is a microservice. That's what everybody's saying. It's wrong, but doesn't matter. Suddenly, domain-driven design got such a huge boost. Like suddenly everybody wants domain-driven design. Suddenly it's cool. With I think we're in the same situation. The problem is not everyone realizes how cool domain-driven design is right now. And for two reasons. Let's go back to the notion of ubiquitous language that we discussed in the beginning of the podcast. That you have to formulate that understanding of the business domain to understand like the needs of the business, the strategy of the business, like the reasonable vectors of change for that business, so that you can later on design them in your solution. How do you do it? In natural language by communicating with domain experts? How are we interacting with AIs nowadays? Using natural language again. So the moment you have that ubiquitous language, your interaction with an LLM is going to be way more efficient. Now, how LLM works? Basically, and people who are AI engineers is going to curse me right now, but for the rest of you, how an LLM works. It reads the whole of the internet, finds the average, and that's the result you're getting, the average one.
Yeah.
Which means if you're not too specific about the business domain, the outcome you are going to get is going to be something that is good for the average company in that business domain, not something that is specific to your case. Now, if you're able to provide that additional context, that additional knowledge about your company, you will get above average result. How can you do it? Ubiquitous language. Again, the same language that is being used for interaction between software engineers themselves, between software engineers and domain experts, and now between software engineers and LLMs. Now,
One
sorry?
question here on ubiquitous language, because I thought about it. What's your go-to solution to document it? Like, do you have like a Confluence where all the company sees it? Is it part of the, I don't know, how do you make it stand out?
Yeah, you have to be a policeman and to make sure everybody uses it
Mm-hmm.
in conversations, in documents. Some people will hate you for that, but you
Mm-hmm.
have to, really communicate the why before the how. If you
Mm-hmm.
communicate the why, usually people understand and go along. In my opinion, that's the biggest test of ubiquitous language. How people are using it, whether they're using it at all. Because to document it, well, you can write a document with terminology and stuff, but it will be a lonely document in Google Docs, and Google
No
will
one will
index
read
it for ads. Yeah, and that's it. Yeah,
it. Okay, got
yeah,
it. Thank you. I
yeah.
think
This is the second part.
second part, yes.
Yeah, so the second part, why domain-driven design is way more important nowadays than before. So the first one was ubiquitous language. Now, before that, I said that in my opinion, two most important parts of domain-driven design are ubiquitous language and bounded context.
Mm-hmm.
Guess what the second part is? Yeah, it's related to bounded context. Why it's important in the AI. AI, at least right now, I have no idea what's going to happen in 5 years. But right now has the same difficulties in withstanding complexity as we do. Let's go back to that balanced coupling model. When you're sharing lots of knowledge across big distances and stuff is volatile, all the 3 dimensions are high, so the pain you will go through is going to be high as well, like very high. Now, why is it so painful? Because when you're working on something, it's really easy to forget that you have to modify something distant in the system. Usually
That's true.
you will forget, you will deploy, and then the production will remind you that that distant part had to change as well. And many other things. For example, you modify something here, there is dependency there, and now you have inconsistent behavior. Inconsistent behavior, it's like a very fancy way of saying you have a bug. Again, it's because of large amounts of knowledge communicate across large distances. AI with limited context window is exactly the same. Now, if you are able to identify module boundaries starting from bounded contexts, then suddenly you have those islands of related things, related functionalities, things that change together. So things that are changed together, they have to change together. They are located close to each other in the same place. The AI, the LLM that will have to work on it, it will be much easier for it to track the dependencies. It's all here. So,
Mm-hmm.
in my opinion, at least nowadays, ubiquitous language is the first thing that makes DDD super important, and the second one is bounded context. Again, bounded context is DDD's way to identify those modular, higher level abstractions in the system.
I love it that we finished and started on the same thing, the same two topics. It's very symmetrical.
Right.
One more question. Besides your two books, which I adore, Balancing Coupling in Software Design and Learning Domain-Driven Design, what are some of your favorite books that you recommend to people?
Software engineering or any book?
Any book. One
Any
software
book.
engineering at least, and then one more non-software engineering I would recommend.
Yeah, so if you are talking about non-software engineering, then the book that inspired me the most and inspired the book on coupling, there is a whole chapter in it, which is, in my opinion, is probably the most important chapter in the book. Yes, inspired heavily by that book. The book is called Scale: The Universal Laws of Growth in Cities, Organisms, and I don't remember. It's a very long title, but the book is amazing. That book simply changed the way I'm seeing the world. So usually I recommend it to everybody. Scale by Jeffrey West.
Jeffrey West. Yeah, I saw it. Nice.
Yeah. Now, software engineering, I'm not going to recommend anything that is modern, because things that are modern are, maybe it will catch up, maybe it will be forgotten. So instead, I will recommend something that was forgotten, unfortunately. Structured design. My favorite book is Composite Structured Design by Glenford Myers. When I was reading it, I couldn't believe my eyes that book was written in 1976, because except for the code examples that were in Fortran or COBOL, I don't remember, but one of those languages, the author talks about the problems in the industry and the issues software engineers are facing. It's like, come on.
It's the same.
It's exactly the same. It's like, okay, so this man, I'm reading the book and I'm, okay, so he is probably talking about microservices, but he doesn't want to say it explicitly. And then, okay, no, 76, come on. Yeah.
That's really cool. Thank you so much. Thank you for joining me, Vlad. It was a pleasure. I hope we covered a lot of stuff. I hope my readers feel like they've learned a little bit about domain-driven design. If they don't, I recommend them they read your book because it's awesome. So, yeah, thank you for joining me.
Thank you so much, Dan, for inviting me. I really enjoyed the conversation.
Thank you. Have a nice day.
You too.